I'd like to introduce the Director of Hardware at Raspberry Pi, James Adams.
Okay, is that's on.
Hey. So thanks so much for being here. I presume there's some people here who maybe are just hearing about Raspberry Pi for the first time, which is commonly the case at Maker Faire. Can you just tell us a little bit about what Raspberry Pi is?
So I have a Raspberry Pi here. We had some slides. There's a technical issue. Hopefully they'll come back. So Raspberry Pi, this is a Raspberry Pi. It is a credit card-sized Linux computer. It is $35. It is created by the Raspberry Pi Foundation. So the history of this is some guys at Cambridge University, they kind of saw a steady decline in kids coming in to do the computer science course, and their kind of coding skills and understanding of computers was kind of dropping off. So the theory was in the 80s, you have the kind of the Commodore 64s and the BBC Micros for the UK guys, and these, the Tandys and all the rest of it. And they kind of introduced this era of programming, and you turn them on and you had to do some programming to even get started. And the books that came with them, they had, examples on programming, and you could get all these magazines like Input Magazine in the UK and various other things. So that era had disappeared, and the kids were kind of onto the PCs and then the iPads and all this kind of thing,
right.
Where, there's much more of a barrier to entry to programming. So they saw this as a problem. They wanted to build a really cheap computer that could be given to kids, so kids could own it. You could plug it into the TV. The parents didn't have to worry about their home PC being, any problems with that, or with the kids playing with the software. So they could own this computer, and that was the dream. And back in 2011, a guy called Eben Upton was working at Broadcom. I actually used to work with him. The processor on this board is made by Broadcom. It was designed. We designed it for mobile phones to be very low cost, and it just so happens that Broadcom were very supportive of Eben's idea. It was a charity as well. It was set up as a charity. It still is a charity, and they were they helped sort of get good pricing, and this team of volunteers from Cambridge kind of went out and got these boards built. Also at the same time, there was some great publicity from the BBC. There was basically the headline was a $25 computer, and that kind of kick-started it. There was this great interest. There was a blog put up on the website, and it just kind of went massive.
Yeah.
So to date, as Matt said, we've sold, I think now it's over 3.5 million of these devices. This one here, the latest one is called the Model B+. It's just a revised model of the original Raspberry Pi with a few sort of tweaks and upgrades, but it runs the same software. You can go out and buy this today for $35.
It's amazing. Now, can you talk a little bit about what you do with Raspberry Pi and what your role is there?
So my title is Director of Hardware Engineering, which sounds kind of boring. I look after the design of the new hardware. I didn't design the very first Raspberry Pi, but I was employee number 2 when this team of volunteers realized they had some money and they also had too much to do, so they employed full-time engineers. And so I designed the new products, managed the kind of the costing and the bill of materials. I worked with the guys who actually manufacture them, from the sort of front-end design stuff all the way down to this. We can't get this transistor in 3 weeks' time. We're going to have a line stop. We need to find 100,000 of these. Can you find a different alternate part, sort of thing? So I get involved in all of that really.
Now, you mentioned the new Model B+. What kind of features does that have? What differentiates it from the previous version?
So the B+, I guess one of the key features, the first model of Raspberry Pi had 2 USB ports. So once you plugged your mouse and keyboard in, you kind of, if you wanted a Wi-Fi dongle or a USB flash stick, you kind of have to use a hub. So we wanted to add another 2 USB ports, which we've done. We've kept it, the form factor, it's the same size. We've added more I/O pins, so for the guys who want to connect electronics to the Raspberry Pi, there's more options. We swapped the SD card to a micro SD card because the big one actually took up a lot of board space, and the micro SD card, we could get it for a good price, and it's just a more robust solution. What else? I'm trying to remember here. Oh, we put mounting holes in sort of 4 corners of the board. And we've sort of improved the power circuitry and the USB hot plugging and lots of little hardware tweaks, basically.
Now, Raspberry Pi has shields, BeagleBone has capes, and now, Arduino has shields, BeagleBone has capes, and now Raspberry Pi has hats.
So we have hats. We kind of coined the term hats internally in engineering. One of our engineers, Jonathan, really wanted to call them hats, and it kind of stuck. So then we had to decide what hats meant. So we just hats stands for hardware attached on top. So we have these sort of, yeah, it's great, isn't it?
So the other ones don't mean anything.
No.
Shield doesn't stand for anything, but yeah.
Yeah, it's one of those things where the name just kind of stuck.
Yeah.
It's like, well, this is a cute name. We need to make it mean something. So the idea with a hat is the previous Raspberry Pi version, there was no real specification for what you could plug into it. And what we wanted to do with the hat was have this kind of form factor, like the Arduino shields and the BeagleBone, where we can say, hey, we have slides. So if we skip through by the next slide, I think. So here's the Raspberry Pi, Model B+.
The Model B+, and I'll keep trying here. You carry on about
the hat is now a squarish shaped board with an I/O connector on it. We specify the size and things so that people know what they can build and where the sort of holes are for putting cables through, so you can connect other things to the board underneath. And one of the other significant things about a hat is it's got a flash memory on it which tells the Raspberry Pi when it's plugged in, it tells it what the board is, so the Raspberry Pi can automatically configure the hardware on the board. So this was something you didn't have in the previous Raspberry Pi. You'd have to look at what board you've connected, understand the hardware on there, load the drivers, make sure there's a significant extra step. So what we wanted to do was at least provide the option that if your board is hat compatible, it will be like a plug and play solution. So this is for the guys who want to use Raspberry Pi but are maybe less technically aware.
Right.
The schools, basically just provide this sort of neat, ease of use.
And so what kind of hats are you seeing being made?
So we've seen, again, if the slide is
yeah, I'll
broken.
keep trying here to get that going.
So we've got one on the slide there's an audio hat, so it's got a high quality DAC on it and headphone driver. So the audio on the Pi is pretty okay, but it's not hi-fi. I think Adafruit have quite a lot. They did a run of a hat a day, which is like several different hats that they prototype and they showed it off on their website. So screens, motor drivers, sort of LEDs. I think Pimeroni have an LED hat that looks pretty cool. And I think any hardware that was sort of designed for the original Pi, you could map it into a hat and you could add this sort of plug and play feature as well. So I think, it's not a restriction on what you can do. It's just you can follow this standard if you like, and it'll just make people's lives easier. They know what they're going to get if they buy a hat.
Right. Now, I'm really impressed with how much the Raspberry Pi has evolved and stayed at the price it has. How much of a challenge is that compared to other work you've done, keeping costs down on the BOM?
Okay, so that's a good question. So traditionally, I've worked in high-tech, sort of, as an engineer designing high-tech, less price-sensitive products. So the Pi was a challenge for me. It's one of the reasons I really wanted, apart from believing in the mission, was a good challenge to get involved in this volume product. And it is a challenge to keep it at the price point. You're battling against inflation and the sort of component costs all the time. We are in the luckier position now, whereas originally the Pi was who knows how many they're going to sell, and it was a lot of goodwill to get the pricing. Now we're selling millions of units, so it is a lot easier to talk to people. And there is still goodwill because we're still a charity. All the money that we make is owned by the charity and used by the charity. But as an example, the B+ board, although it's got more sort of functionality, the production price is basically the same. I mean, it's very slightly less, but we've been able to effectively do some work, get the pricing down, and it's all iterative. We'll do it over a long period of time. We'll talk to the connector manufacturers, and we'll talk to other suppliers, and we'll kind of gradually get the price down on these things. And then, with the B+, we could spend the money on adding extra USB connectors and, revamping the board to give people something extra and keep it at the same price. And we think the price point is a really important thing. So that shows what happens. And, on a day-to-day basis, I'm spending quite a lot of time talking to people, trying to get pricing down on all the various components.
Right. And where do you see the Raspberry Pi going? Let's say just talking about the hobbyist and academic world, and we'll leave products aside for a bit. Where do you see it going and evolving from a hardware perspective?
So, okay, from a hardware perspective, I think The form factor is really interesting. It's kind of iconic now. I mean, it was at the beginning. I think the sort of credit card size is actually a real winner. If you've got this kind of hardware, you don't want to make it too big. You know, if you're carrying around these big dev boards. I think that future Raspberry Pis will probably have a very similar form factor. I assume and I expect they will evolve with, you know, as the I/O changes. You know, USB just bring out this new standard sort of Model C connector, and maybe HDMI will be superseded by something else. But you know, this is a nice form factor, and it's a nice form factor for both an actual computer, which is obviously what it is, and also something that you can sort of embed into projects. So I think it's going to stay recognizably a Raspberry Pi, but obviously, you know, technology marches on, and you know, eventually there will be more Raspberry Pis and different versions of Raspberry Pis, I'm sure.
Right, right. Now, I mentioned this in the beginning, and I think this is really cool and big news, that people who are making Raspberry Pi projects have a route if they want to turn their project into a product. And can you talk about that?
Okay, so what we've created for the guys who use...
Oh, there we go.
Hey.
Okay, so if I go back,
right, so
that's the hat.
That's the hat.
And there's the compute module.
So this is the compute module. So I don't know if anyone can really see that at the front. So it's the size of a laptop SODIMM memory module. Obviously the pins are all different. We've basically repurposed this form factor to put the Raspberry Pi processor, memory, and the other chip on that board is embedded SD card, effectively, or eMMC for people who are techie. So that is a bootable computer if you give it power and you kind of connect up the I/O appropriately. And it's the idea is that we saw a lot of people building Raspberry Pis into things, right, into actual commercial products, and you know they were kind of suffering a bit with the form factor. They loved the functionality, they loved the software, they loved the camera that you can buy. That's been built into all the projects, and they just put up with the form factor.
Right.
So this was really a way to provide the Raspberry Pi technology, still at a cheap price, but that could be embeddable into products. And the other significant thing with this is it's $30 in volume. So you kind of, the volume is small, right? 100 units is the $30 price point. So we wanted people to be able to hit these kind of asymptotic price point with this thing at low volume. So if you're building 100 or 1,000 of something, you don't have to build the 10,000 to get the price. So we're leveraging the fact that we can buy this processor and memory and flash in high volume, and you know, pushing as much of that price saving down onto people, you know, into this module. So, so that's kind of what it is, and it allows you to build something with a Pi and then turn it into a commercial product.
And we've talked about this before, that Linux on modules isn't a new thing, but I guess that would be the distinguishing factor, is that the fact that you've got this community of people, you've got a cheap, low volume step to make your way, right?
Absolutely, and I think it's worth saying that the software is, you know, as much, if not more, of an important part of this equation than just the hardware. You know, the Raspberry Pi software has had an incredible amount of effort gone into it in the lower levels, in the higher levels. You know, we keep the kernel versions all updated. We do a lot of work with contractors and internally to sort of improve all the software. We've got a new web browser that's, you know, just come out that's actually very usable now on a Raspberry Pi, despite the fact the processor isn't the fastest in the world. You know, we've done a lot of improvements to underlying software for making things like XBMC faster. You know, there's a ton of stuff that we've done, and you know, and it's still continuing. So, you know, it's got a bright future.
That's great. Now, Maker Faire Bay Area, right before Maker Faire Bay Area, we saw a Kickstarter launch called Auto, a camera that used a compute module. And when we were at Maker Faire, I was at Maker Faire, and we got word that someone had it on site. And we were racing around trying to find Auto because we wanted to see the first product ever made with the compute module. And it happened really quickly, wouldn't you say, that already we've got, you know, people using it?
Yeah, I mean, Auto is a great example of use of the compute module. And these guys came to us with a prototype, which was a Raspberry Pi and a camera in like a Perspex box, and they'd done the software, and they had this really cool idea. And then we showed them the compute module, and they're like, right, we really need this. So, you know, that's exciting, right? I think, you know, it's great. We know we're going to sell compute modules to the sort of like the engineering companies and the guys who know how to use technology and all the rest of it. But what excites me the most is seeing the kind of the little guy being able to leverage this technology. You know, technology that was basically mobile phone technology a few years ago. You would, you know, as a hobbyist or a small volume manufacturer, you'd never be able to get hold of this. and now it's in people's hands. They can actually use it, and it's, you know, I'm excited to see what people do with it.
And you have your own side project that uses the
I
compute
do.
module as well. Can you talk about that?
So I don't know if the slide is
Yeah,
probably,
sure. There we go.
well, hey. So this is a project called Slice. It's designed by 5 people. I'm kind of one of the guys on the project team. I'm doing this in my spare time. I designed the electronics for it. It's a media player. It runs XBMC, but with a custom skin on it. And we've done sort of some driver and various bits and pieces to sort of make it. The idea is to make it a very easy to use experience. So XBMC is great software, media player software, but it is a little, you know, there's a learning curve. So we've tried to remove that and also put all this stuff in a package so that it's kind of turnkey. You know, you can build this kind of functionality out of a Raspberry Pi and all sorts of different things. But we've already done that. We've put it on a board. We've got audio, you know, high quality audio, real-time clock. What else have we got on there? The sort of USB, Ethernet, optical out. It's all packaged up nicely. We've kind of done all the work. And it's kind of a higher end thing. It's in a machined aluminum case. It's supposed to be a nice bit of design that you can, you know, put underneath your TV, and it's got these sort of reactive LEDs that can do patterns and status of what the media player is doing. But it's also open, so people can run any software that you can run on a Raspberry Pi. We have our Kickstarter going now. I think there's 5 days left. So we're funded, but if anyone wants to pledge, please feel free.
And there's actually, Slice has a booth here at Maker Faire. If you know where all the Arduino stuff is and the Raspberry Pi stuff is, it's really close. It's really right behind the Raspberry Pi.
Behind the
booth.
Raspberry Pi stand.
You can see the Slice yourself there and try it out, and that's great. Can you talk a little bit about how you working on this product has gone and helped the compute module itself and Raspberry Pi itself?
Absolutely. So before we got involved in this, from Raspberry Pi, there's myself and my sort of other half in sort of software is Gordon Hollingworth. He's also involved with this. So we were approached by these 3 guys with the idea, and initially it was just as advisors, and you know, can you help us with this project? And very soon we got involved as sort of actually providing a lot of the engineering, because it was clear that this was a really great idea, but you know, they needed that sort of help. And we approached, you know, Raspberry Pi and said, can we do this in our spare time? And they thought about it, and actually Eben was really fine with it, because what it's done is it's allowed us to see firsthand what it's like to build a product with a compute module. And we've actually found, you know, software things that we've changed now, and you know, it's basically driven an understanding of this sort of productization. So we're making changes at Raspberry Pi based on what the experience is with the compute module in this product. So actually, it's, you know, it's been a really good benefit to both sides.
That's great. That's great. Now, if we have some extra time, we can take some questions if you like.
Yeah, I'd really like to take some questions.
Okay, great. So if you have a question, I guess stand up, speak loudly, and we'll repeat it for the stream. Right there.
With the new form factor and the rounded corners, does the B+ fit in an Altoids tin?
The question was, with the new form factor and the rounded corners, does the B+ fit in an Altoids tin?
I love this question. The answer is unfortunately no. We keep getting asked that. We should just put it on the website, like it does not fit in an Altoids tin.
There should be you should just create a new candy or gum or something that has that.
Yeah, absolutely. We need like raspberry mints.
Yeah.
Fits Raspberry Pi.
Yeah. You could make millions.
Yeah.
Any other questions, sir? Yes.
So the foundation said that originally they wanted to produce these pies for schools.
Yes.
And now with the makers and hardware enthusiasts using this, and now businesses building models on this, has the foundation found out that their goals have changed? Have they succeeded? Have they failed?
Shall I repeat the question?
So the question is that if the Raspberry Pi is moving in this direction where it's being integrated into products, and it's in addition to what they're using it in schools and for academic purposes, has the mission of Raspberry Pi changed?
Yeah. So the mission of Raspberry Pi definitely hasn't changed. Raspberry Pi is still a charity dedicated to teaching kids computing. I mean, we are and we continue to spend a lot of money on creating educational resources and going out and teaching people how to teach, as well as just doing things for kids. So kind of internally to Raspberry Pi, we're split into two sort of entities. There's engineering, which is kind of where I sit, and we're the guys who kind of build the hardware and do the next products and you know, kind of make the money, I guess. And then we've also got a great team of guys like Clive Beale and Carrie Ann, and the guys who we've recruited who are ex-teachers or people who've just got involved from the beginning, who are really great at sort of educating kids. We run something in the UK now called Pi Academy, which is a sort of becoming a template for something that I think will roll out more, you know, more as it comes together, which is to teach teachers how to use Raspberry Pi, but also how to teach with Raspberry Pi. And we also create, you know, materials for teachers to just download where it's kind of all put together, so there's an easy to pick up package. And actually in the UK now, there's computer science has become, just this September is now a new part of the curriculum. So they've chucked out the old learn to do PowerPoint and Word, and it's actually now, you know, learn to program. So
Is that as a result of the Raspberry Pi?
I like to say it's because of Raspberry Pi. I'm pretty sure it's just one of the factors that's pushed this on the government, right? And we've definitely been lobbying people to say, you know, this is a really important thing, and I'm really happy that it's happened. But there is this knowledge gap that needs filling with the teachers, and they kind of need, you know, it's kind of scary to all suddenly have this thing, you know, how do you teach it? So.
And if someone buys 1,000 compute modules, the money that's made from that, it does go towards education.
Exactly.
Right? Okay.
So it's just another revenue stream for the charity, the foundation, to, you know, spend the money on education. I mean, we obviously spend money on engineering as well to sort of, you know, sustain what we do. Right. But you know, we've a short time ago we launched this £1 million education fund. So I guess that's $1.6 million. Which is sort of a matching. If you have a project that's around computer science, teaching kids or whatever, you can sort of ask for money and we'll fund 50%. If you have 10,000, we'll give you another 10,000.
That's great.
Sort of things like that, and we're slowly growing the team as well of the education side of things, as well as engineering.
Right. We have time for one more question, right down here.
So for the maker community, the Raspberry Pi is awesome, but if you hand it to your average fifth grade teacher, even one that's used, you know, computers before and has even taught computers, it's kind of scary. You know, you've got exposed pins, you've got, you know, just this Linux, you know, they could be familiar with Windows or Mac, and it's been kind of, you know, I've been advocating for the RPi and, you know, my local school system, but it's kind of like, hang on a sec. You mean, okay, the computer's there, but then what else? You know, my question is sort of like, do you think that there's a next step moving forward for the foundation to make it easier for schools who have to?
The question was basically what steps are being taken to make it easier for adoption of the Raspberry Pi.
Yeah. So I mean, we're well aware that there's a significant learning curve for people like teachers. I mean, and anyone, not just teachers, but you know, people who aren't really very familiar with computers. You know, we are well aware of this, and we are working on ways to try and, you know, fix that sort of, you know, reduce that energy barrier. I think the work that we're doing in education is going some way to doing that. This sort of teaching the teachers how to use Raspberry Pi. You know, that's a good example. I think people actually find, you know, you only need a small amount of instruction, and then all of a sudden they get it, right? It's actually not a super difficult thing to learn if someone's there to teach you, but it's completely understandable that people get scared about it, and you know, it's a different thing, it's a new thing. I mean, there are also great books out there as well now. There's a lot of literature on Raspberry Pi. I think it's a tough challenge, and we're continuing to work on it. And hopefully, you know, you'll see progress moving forward.
Great. James, thank you so much for being here. If you have any more questions, Raspberry Pi is